Hello children, welcome back to the physics class. So today let us discuss in detail regarding the worksheet number 3 of wave motion. So here we go with the first question. The points on a wave which are in the same state of vibration are said to be in the same, is it phase, time period, frequency or wave motion. So what they are saying is, if you suppose that a wave is passing through, okay, whenever a wave passes by, the points which are in the same state of vibration, whether you consider these 3 points or if you consider some point somewhere here, here or here or any other specific point, say something like at this point, at this point, at this point. So, the same state of vibrating particle, they are said to be phase. They are in phase, same angle, same amount of variation. So, now it is going downwards. Okay. All cases when it is going downwards, they represent the same state of, same phase. Okay. So, the points on a wave which are in the same state of vibration are said to be in the same phase. So, the correct option is same phase. Okay. Phase indicates at what angle they are displaced from the mean position. Frequency, what is frequency? The number of cycles or the number of vibrations per second itself is called as frequency. How many times it is vibrating, the wave particle is vibrating, is indicated by frequency. Time period means how much time in order to complete the to and fro motion, going up, coming down and again coming back, reaching the same mean position, that itself is called, the amount of time taken is called as your time period, and the speed with which the wave travels is called as wave velocity. So, but what is phase? So, when, at what angle, at what state do they represent? The particles are at what state? Whether they are moving upwards, downwards or at what angle, everything is represented by phase. So, the points on a wave which are in the same state of vibration, is called as phase. Moving ahead with the next question, children. The reciprocal of time period of the wave is called as dash of the wave. Children, as we know that wave velocity V is equals to lambda by T. Velocity of a wave is given as V is equals to lambda by T, where V is wave velocity, lambda is wavelength of a wave. What is wavelength? Suppose if you consider a complete wave, mean position going up, passing through the mean position, again reaching back the same position. This complete length of the wave itself is called as a wavelength. And the time it has taken to complete this up and down motion is called as your time period. Okay. So, the time taken for one complete vibration is called as your time period. And always remember that the value of 1 by time period can also be taken as frequency. 1 by time period is also nothing but frequency. So, if V can be written as lambda by T, means it can be written as lambda times of 1 by T. Or V can be written as, instead of 1 by T, I can replace with F. So, lambda times of F. So, these are the relations for wave velocity, wavelength, time period as well as frequency. Now, let us look at the numerical part, children. The reciprocal of time period, of the wave is called, what is it called as? Frequency. So, where is the correct answer? Here, second one. The reciprocal of time period of a wave is called as your frequency. Now, let us look at the next question, children. Third one. 1 vibration per second. So, already in the first concept, I told you that the number of vibrations per second or the number of cycles, okay, the wave is moving on, that is called as your frequency. At what frequency the wave is vibrating. Okay, so frequency is nothing but the number of vibrations per second or the number of cycles per second. So, 1 vibration per second is called as, is it frequency or 1 hertz or time? It's not time period or it's not kilohertz. Okay. So, actually, I told you the definition of frequency as number of vibrations per second. Okay. But here one vibration, number of vibration they gave it as 1, and per second time is also they gave it as 1 by 1. So as the formula for frequency is 1 by t. Formula for frequency is 1 by t. 1 indicates the reciprocal of time period. Here for each wave, n number of wave means n times of 1 by t. So number of vibrations is n times it is vibrated, and time period of each wave is t. Okay. So this is nothing but this value itself is gives 1 upon 1 gives your frequency. And what are the units of frequency? So number has no units, time period is measured in seconds. So either it is can be measured in second inverse, or the specific unit of this frequency is measured in hertz. Symbolic notation is Hz. So 1 upon 1 you will be getting it as 1 Hz, that means 1 hertz. Values itself are given, number of vibrations they gave it as 1, time also they gave it as 1. So finally you are getting it as 1 hertz. Though it indicates frequency, but when the values are substituted, you won't say it as frequency. It should be 1 hertz. Definition and values make a difference. So moving to the next question, children. Fourth one, the distance travelled by the wave in one time period is. So what you are saying is distance. So distance is nothing but the amount of path length. The path length means what is travelling, that amount of path is covered by the wave. So here the wave covers certain distance, and that path length is called as the length covered by the wave. So hence wavelength. So what is it called as? Wavelength. So the distance travelled, the amount of distance travelled by the wave in one particular time period, it's this total distance itself is called as wavelength. Moving to the fifth question, the SI unit of wave velocity is. Children, whatever be the velocity, generally formula for velocity is velocity equals to displacement by time or distance by time. Distance covered by time. And here the distance for wave velocity, we measure that as wavelength upon time period. Okay. So this length always measured in meters, distance always measured in meters, distance covered by wave always measured in SI system, it is measured in meters, and time is measured in seconds. So velocity of a wave, that is wave velocity, units in SI system is meter per second. Hence the second option must be true. So let us now look at the sixth question. What is the sixth question? The relation among wave velocity, wavelength and time period. So this already I told you. So what is the relation between wave velocity, wavelength and time period? If V is the wave velocity, lambda is the wavelength and T is the time period. The relation between wave velocity, wavelength and time period is given as V is equals to lambda by T, and hence the second option must be true. V is equals to lambda by T. Moving ahead with the seventh question, children, the maximum displacement of the particles. The maximum displacement of the particles of a media from their mean position during the propagation of a wave. We see, look at the wave, children. So here I am plotting it out, a wave something like this, motion. Okay. From here to here, this total length going up, coming down and again reaching back to the same position, that length itself is called as wavelength. And from here to here, mean position, and this is your extreme position, this length is called as your A. A indicates your amplitude, whether it goes to the positive point or again from mean position to the other extreme position downwards, that also this total length itself is called as amplitude. Here also amplitude, here also amplitude. So the maximum displacement of the particles of a medium from their mean position during their propagation is called as amplitude. From mean position, how far is it traveling towards the extreme positions indicates amplitude of the wave. So third option must be true. Now look at the 8th question, children. Number of cycles. This already I told you, number of vibrations per minute per second or number of cycles in 1 second. Both indicates frequency. So the number of cycles in 1 second is called dash of the wave. What is that called as? Frequency of the wave. Frequency is defined as a number of vibrations per second or number of cycles in 1 second. So number of cycles in 1 second is called as a frequency of the wave. So now look at the 9th question. So what is 9th question? What will be the frequency of a wave whose time period is 0.002 seconds? So what is given, children, here? Given that time period is equals to 0.002 seconds. And you're asked to find out the value of frequency. Already I told you the relation between frequency and time period. Frequency is equals to 1 by t. Frequency equals to 1 by t. This is 1 by how much the value of t is given? 0.002. Isn't it, children? So 1 by 0.002. And this can be written as 1 by this 0.002. May I write it as 2 into 10 power minus 3? Decimals here. 1, 2, 3, 3 decimals I am bringing out. Okay. So hence I can multiply with 10 power minus 3. So 0.002 can be replaced with 2 into 10 power minus 3. I don't know whether you know this or not. See, children, 0.2 is nothing but 2 by 10. Or if you bring this 10 upwards, it can be 2 into 10 power minus 1. Similarly, 0.02 means 2 upon 100, or if this can be written as 10 square, or this is equals to 2 into 10 power minus 2. 10 power minus 2. Similarly, 0.002 is nothing but 2 upon 1000. 3 decimals, 3 zeros. So this is nothing but 2 upon 10 cube, or 2 into 10 power minus 3. So this is what I wrote. 0.002 is replaced with 2 into 10 power minus 3. So solving this ahead, f is equals to 1 by 2. 10 power minus 3, if it is brought up, then it will become minus 3 brought to numerator, then it will become 1, I'll keep it here, then it will become 10 power plus 3. Minus 3 when brought to numerator will become plus 3. So what is the value of 1 by 2? 1 by 2 is nothing but 0.5. Half 1 by 2 is 0.5 into 10 cube. 0.5 multiplied by 10 cube. 10 cube is nothing but 1000. So 0.5 into 1000. You'll be getting this as 500. And what you're calculating? You're calculating the frequency. Frequency measured in hertz. So, how much is the value of frequency? 500 hertz. So, first option is true. I hope you understood. Formula for frequency is 1 by t. 1 upon given value 0.002. 002 is nothing but 2 by 1000. At 1000, you can directly take it up. If you are confused with this model, I can even tell you in another mode, children. This is 1 by, this value can be written as 2 upon 1000. This 1000 can be carried upwards. So this f is equals to 1000 upon 2. And after simplification, 2 goes 5 times 10 and this is 0, 0. And hence the correct option is 500 hertz. So let us also look at the next one. 10th question. What will be the time period of a wave whose frequency is 400 hertz? So what is given? Frequency is given as 400 hertz and you are asked to find out time period. So we need to get the relation between frequency and time period. What is the relation between frequency and time period? Frequency is equals to 1 by t. But here f is given, t you need to know. So cross multiplying. If f is equals to 1 by t, then t must be equals to 1 by f. Taking the reciprocals, reciprocal of f is 1 by f, reciprocal of t is 1 by t is t. t. So if f is equals to 1 by t, t must be equals to 1 by f. So you're asked to find the time period. What will be the time period? So this is nothing but 1 upon, how much is the value of f? F was given as 400. So 1 upon 400. And this 1 upon 400 will be something like 1 by 4 into 100. 1 by 4 into 400, I wrote it as 1 by 4 into 100. How much is the value of 1 by 4? Half. 1 by 2 is 0.5. Again, 1 by 4 is 1 divided by 4 is 0.25. 0.25 divided by 100, you will be getting it as 0.0025 seconds. Time you are asked to find out. So time measured in seconds. So decimal 2 by divided by 100, you have to shift 2 more decimals towards left side. So additional 2 zeros you have to keep it. So 1 by 400 is 0.25 upon 100, and that is equals to 0.0025 seconds. Moving ahead with the 11th question, if V, lambda and T represents the wave velocity, wavelength and time period of a wave, which of the following relations hold good? What is the relation, children? V is equals to lambda by T. Is that there? Nowhere V is equals to T by lambda, but we got it as lambda by T. So this is a wrong option. Okay, if you bring this T other side, then what happens? Vt is equals to lambda. Vt can be written as lambda. So lambda equals to Vt. So first option is true. V equals to lambda by T. T bringing here Vt equals to lambda. Correct option. If you want to find out the value of T, T is equals to lambda by V. T is equals to lambda by V. But here they gave it as V by lambda is a wrong option. Now, if you want to find out 1 by lambda means reciprocal of this. If you want to find out reciprocal of this, you have to find out the reciprocal of this. 1 by lambda must be equals to 1 by Vt. So, it's not V by T, it's 1 by Vt. So, all options are false except this. Yes, except this. So, first option is true. Lambda equals to Vt. Let us now move to the last question, children. Assertion reason type problem. The frequency of a vibrating particle decreases as time period increases. Yes, because of the reason f is equals to 1 by t, f and t, how are they related to each other? They are inversely proportional to each other. They are inversely proportional to each other. That means, what does inversely proportional means? When time period increases, the value of frequency decreases. Similarly, when time period decreases, the value of frequency must increase, because reciprocal. If one decreases, the other must increase. So what they say is, the frequency of a vibrating particle, decreases with as the time period increases. Whenever time period increases, the frequency of a particle decreases. Say yes or no? Yes. Why? What is the reason behind that? Because f is inversely proportional. F is equals to 1 by t. This is the reason and this is the correct statement. So, from this we can conclude that both assertion as well as reason for that both holds good. And hence, the only option that is both assertion and reason are true, and reason is the correct explanation of assertion. Because of this condition, that is f is equals to 1 by t, only we are able to prove that as time period, frequency of vibrating particle decreases as time period increases. So, this is the statement. Okay. So, go through this, children. So, we have completed this worksheet.